Today we are going to see about Open Standard Routing Protocol using Cisco Packet Tracer. It is otherwise named as Interior Gateway Protocol, where we will be setting up different area or locations, which is in a large scale and a complex way to set up the network. So we will be using this open shortest path first, which is the dynamic routing protocol. So it will be helpful for a multi-scaling under like environment. For example, we can consider this research paper like here Delhi, Jaipur, Kolkata, Hyderabad, Bhopal, Mysore and Chennai. These are the different locations termed as a single area. Actually, this has been mentioned using the GNS3 tool, but we have done with the Cisco Packet Tracer. So we know that it will be using the SPF algorithm to calculate the best routes to have the routing table. So the number of hop counts can be counted, and then we can establish in a very fast moment in which the routing can be made, so that the scalability has been achieved by the enterprise network or the small or a large scale company oriented network. So it will be very helpful. So the OSPF is like helpful in the large scale cost reduction also. So we will be using the multicast address to be 224.0.0.5 to and 224.0.0.6 for the routing updates and all. So when we come for our Cisco Packet Tracer, I have drawn with the rectangle shape with the area Pondicherry University. So we know that the OSPF routing is entirely designed within the area only. So in this picture also they have mentioned this as OSPF area 0. So for many different areas also we can launch this, but we have done with a single area, one area alone. And then here the network is established with the routers and end devices or any in-between switches, firewalls, everything can be the topology diagram, whichever we like, we can design accordingly. And then the routing table is very well maintained with the help of the over the each and every routers whichever we have it in our network or area. For example, any area which is termed to be area 0 is the initial area or the first most area, which is acts like a distribution of routing information over the other coming areas. Here we are having only one area, but if we are having one more than two or three areas, so area 0 will be acting as a transit router between this. So area border router is also there. So the OSPF not only we can have as internal router, but also we have the area border router and area border boundary router and backbone router and all. Backbone router is normally area 0 we used to say, and for the internal router it interfaces to the same area only, that is link state database that will be used up. We know the link state database and all, where the packets contains the informations of various types like 1, 2, 3, 4 to 11 and all. So in this OSPF router ID we will be having with the IP address version 4, which is 32 bits, and then we will be doing the manual configurations and select the highest IP address of loopback interfaces and all, and then select the IP address and physical interface over the routers. So altogether we can come to the understanding that this OSPF Open Standard Routing Protocol is helpful for the multi-vendor or a complex and enterprise-like structure to set up the network infrastructure. So it is gives the cost to be equal to the multiple path routings in the by seeing the routing tables and all. So also the number of hop counts can be counted, and the areas can also be subdivided. For example, we have here Pondicherry University. For example, we can have Nagpur University, Jawaharlal Nehru University. Likewise, different places, universities, different areas. We can subdivide the areas of the universities and match this protocol to have the cost reduction. Likewise, we can apply for the a great giant MNC companies surviving in the different locations of the regions in the world. So it is very much scalable, but we won't have the periodical updates like RIP protocol and all. Because it uses the less bandwidth only for transmissions and all. So we will be having around the tables like routing table, topology table, and neighbor table in the OSPF. And then it is also termed as a classless routing protocol with CIDR and VLSM, that is variable length subnetting and all. So now we have designed the area one area node, which is area 0. We will be mentioning the starting backbone one with the routers, 2 routers, network routers, that is 1 and 2, with the loop access 1.1.1.32 and 2.2.2.32. So the two PCs are connected with this, and the gateway has been set as 10.0.0.01 and 10. And for the PC2 we have set 192.168.0.1, and the IP set to be 192.168.0.2, and here the IP for the PC1 is 10.0.02. So with the subnetting 24 and 24, we have placed it over here with the loopbacks also. So this loopback interface, initially we have stated that there will be the router ID where the IP address the OSPF will be using. So the loopback interface is configured with the IP address. So here we have mentioned it. Whenever the OSPF prefers a loopback interface over the interfaces, it chooses the highest IP address among all the loopback interfaces. So that one we have to consider. So this loopback will be acting like a virtual interface in the Cisco routers and all. So it is not a physical interface like a fast Ethernet or a gigabyte internet interface. It is a virtual and a logical one, we can say. So this is very helpful in many of the cases, like IP address is determined with the routers of the router ID or the OSPF, where it is logically present. So loopback interfaces are used as termination points for the bridging and all route bridging which are happening in the remote level, and for the data link switchings and all. So it is always look for the higher IP address, that we have to remember. So loopback is normally in the router configuration. We will be writing a saint space loopback. Within loopback interface number we will be writing. So now we can see what are all the things we have done with this. So now we are going to configure the OSPF over the routers R1 and R2 which are connected in the network, so that this PC1 and PC2 will be pinging each other. So we are going to see how this happens. Like, so we know the process ID we have given as 1 for the OSPF, and with the area 0 we initially mentioned up, and all the loopback IDs and the IPs and all mentioned in this topology diagram and all. And then the gateway also we have set up for the PC1 and PC2, which we have already set and configured. So it will be helpful in the OSPF configuration to focus specially. So what we have done initially is in the router configurations. First we have take the network router 1. So here in this, initially have done with the enable configuration. In the configuration terminal we have done. Once done that, I have mentioned with the router OSPF 1 in this router, so that we are able to enable the OSPF protocol on the router by assigning the process ID to be 1 to this new OSPF. That's what I have mentioned here. Router, this is OSPF router ID and process ID to be 1. And after that, the same thing I have done for the router 2 also. And after doing this, I have enabled the OSPF on the router interfaces which are connected to the each other things. For example, area 0 is I have mentioned. So the network I am mapping initially with the 12.12.0 to 0.0.0255 to be the area 0 in the network. Here we could see this thing, and then again I mapped this to the 10 point, that is to this IP I have mapped it. So we are done with the router 1 network. So after that, the same thing I have done for the router 2 also. In the router 2, the same configuration, that is I'm processing the process ID 1 to the OSPF over the protocol, over the router, or the OSPF protocol on the router 2, and then I'm mentioning the same network OSPF, enabling the OSPF on the router interface connected to each other with the network ID, that is 12.12.12.0 to 0.0.255 area 0, which is mentioned here. Here we can see it. So in the router 2 have done this, and then again I have pinged with the IP address of the PC2 machine network 192.168.0.022 to 0.0.255 area 0. And then now I wish to trace my IP route in the router 1 and router 2. In the router 1, while I'm tracing with the command show IP route, I could get the details like C, and O. C is for the connected and O is for the OSPF. Here mentioned it. Okay. So the OSPF 192.168.0.0 with the /24. This is actually for the PC2 is via 12.12.12.2 has been connected. Likewise, it has been giving the information over the. So when the connected with the subnet 24, so this is loop back to the 0 position, so which is directly connected, that is point to point. Likewise, connection is made up. The same information we have got in the router 2 setup also with the 192.168.0.024 has been. But here the connection is made to the 10.0.0.24, which is subnetted, which is one subnet we are having here. But in this case also likewise mentioned here. So now to verify that we are connected on having the connectivity and the routers are connected between our router 1 and router 2, we have done with the command show IP route. So likewise we can do the verification that routers using the pinging command between the PC1 and PC2, and likewise to the PC2 to PC1, from here to here and here to here. So we have done with the PC1. So I have pinged from PC1 mission. Here we could see this from opening the terminal command prompt. And so here I have pinged with the IP address of the second PC machine. So here we could see 192.168.0.2 with the command. So around time to live is 126 with the time limit 7 milliseconds, 6 milliseconds, likewise with the bytes of 32. So 0% of loss. We have sent 4 packets and received 4. So the average time has taken as 6 milliseconds and maximum 7 milliseconds. Likewise, we have got the information from while we are pinging the command from the PC1 machine over the IP address of the PC2. Likewise, we have done for the PC2 also with the command 10.0.0.2. Here we have written PC1 IP address. So here also no data loss. We have received with 100% packet transfer has been sent and received equally. So pinging statistics of the IP address of PC1 machine over the PC2 terminal, we could get that all the data are not lost, and it is having an average time to basics and maximum time is to OGBC 6. Thus we are done with the OSPF implementation with the area 0 Pondicherry University. I have mentioned it. Thank you, sir. Thank you for your time and consideration.